Welcome back to Ride On Academia. We are still on our series on the set theorem, and in this video we are going to be looking at the Venn diagram. Okay, now our Venn diagram is a graphical representation, a pictorial representation of our set theorem. Okay, we want to see how we can express set using the Venn diagram. Now we have something like this, all right, like a box, right? Now this box now stands for the universal set, all right? The universal set is always outside. It's always outside, all right? So the box now is standing for the universal set. Then we have sets in between. We can have two sets, we can have three sets, all right? We can have two sets in between. Now if this is our set A, as the case may be, right, the circle here, all right, down to the intersection stands for all the elements of set A, right? And then the next circle can stand for all the elements of set B. Okay, now this is where this the set intersect. We call this portion the intersection, right? And then outside like in the box now, outside of the circles in the box, we call this the neither. All right, those elements in the universal set that is not part of set A or set B, those are where those elements fall. All right, now we're taking a question and then we'll be applying it to our set using our Venn diagram. All right, now we have that in a class of 500 students, 50 own television. In a class of 500 students, 50%, okay, own television, 30% own radio, all right, while 20% own both television and what radio. All right, now we have that our universal set is a class of 500. That means this whole set must be equal to what? 500 students. All right, so in a class of 500 students, 50% own television. So I'm going to be using a T, okay, for television. Let's use a T, all right, T for television. Now 50% of 500, that's half, right? So that means this must be equal to what? 250 people. All right, this entire circle for T must be equal to 250 people. That's 50%, right? And then we have that 30% own radio. Now this is our radio. Let's use our R for radio, right? R for radio. 30%, okay, that will be giving us 150 students, right? So that's 150 people own what? Radio. Are we there? 150 people own radio. And then that means this entire cycle also must add up to what? 150 people. Now we have that 20%, okay, 20% own both radio and television. That means the intersection, all right, people that has radio and they still have television, all right, that's this portion, all right. People that owns radio, we have about 20% over 100 times our universal set, all right, own both radio and what? Television. We're going to be having what? 100 people. All right, so if we have, now let's explain our universal sets quickly. So if we have 100 people that own both television and radio, right, that will also mean people that have television alone. Okay, if you want to know about people that have television alone, that's television only, which is just this portion without the intersection, right? People that owns television only, it means are going to be less than 100 from 250, right? That is, people that have television only should be 150 people. So that when you add 150 plus 100, all right, people that own television will not be giving you 250. The same way when we want to talk about the radio, people that own both television and radio are 100 people, right? So if you want to know people that owns radio alone, that is this portion. So when we have only, it's talking about just this portion without the intersection, right? But when we have there's no only, when there's no only, we're talking about the total. Like let's say people that owns television, we're talking about the total circle, right? But when we say television only, it's just this portion, all right? Now the same way, people that own radio, that's the entire circle for radio, is equal to 150. So people that own radio only, that's this portion, okay, we'll have to be subtracting this intersection, which is 100, right? So we'll subtract 100, that will giving us what? 50. That's 50 people owns television was only. Are we together? Now we are asked to find how many people neither own a television or a radio. So there is a possibility that there are people in this class, all right, that do not even have a television or a radio. So that's why the outside this circle is made for neither, okay, people that do not have either of these. All right, so the format we're going to be using now is that since we have gotten this and this and this, we're going to be adding, let's call our neither x, okay, we cannot say people that do not have any of this is equal to x people. all right? But we know that everything here, like I said, everything here must sum up to our universal set, all right? So since I've already made this simple, we'll just be adding 150 plus 100 plus 50, okay, plus x should be giving us 500, which is our universal set, all right? Now I've been able to subtract 100, right? So we've gotten our television only plus our intersection, right, plus our radio only plus people that do not have either, okay? The sum of this must give us what? Our universal set, all right? Now let's continue adding. We have what? 300 plus x to be giving us what? 500. Now we can make our x to stand alone, right? So our x will be equal to 500 minus 300. That means our x is what? 200. That is to say 200 people do not have what? Either television or a radio. Are we together? Now the next example we are going to be looking at is when we have 3 elements. Like what we are seeing now, we just have 2 elements, right? So we'll be checking the next example where we'll be having what? 3 elements. Now we are given that, okay, we are given that 20% of the people in a street own a dog, all right? Now let's also, like I said, we use this rectangular box to represent our universal set, right? Now we have that 20% of the people in a street own a dog, right? 30% own a cat, and 40% own a bird. So we have 3, okay? There are 3 elements: people that own a dog, people that own a cat, people that own a bird. Now if 5% own both a dog and a cat, right, 4% own both a dog and a bird, and 3% own both a cat and a bird, all right? Now 1% have all the 3. That's 1% has both bird, dogs, and what? Cats, right? Now what percentage of the street own at least 1 dog, cat, or bird? Now let's go and solve that quickly. Now we're going to be having 3 elements, right? And then, so if you can see this box, this circle, right, we have element that intersect this in element right now intersect, has a portion where it intersects just with the next one, right? Okay, let me just label them. So 20% of the people in a street own a dog. 20%, in this case we don't know the number of people, so we'll be using 100% for our universal set is equal to 100%. So 20% own a dog. This is our dog, right? D for dog. Own a dog. 20% own a dog. 30% own a cat. So C for cat. Let's be using our 30%, right? Own a cat. And 40% own a bird. So B for bird. Let's use B for bird. Okay, 40%. Right. Now, as you can see, this portion is for where we have just people that own a dog and a cat. They'll be intersecting at this place, just a dog and a cat, right? This one is going to be more, the work is a bit more complicated, right? But we can look at it carefully, okay? Now, when we have a dog and a bird, you can be seeing them here, right? This is for a cat and a bird. We can be seeing the intersection here, all right? And then lastly, people that have all the 3, as you can see, this portion is for them, okay? Now, let's continue. We have that if 5% own a dog and a cat. So when we talk about dog and cat, all right, dog and cat, just we have 5%. That can also mean what? They did not say dog and cat only, right? Dog and cat only. So when we have dog and cat, we're talking about this portion. These people here own a dog and a cat, right? So this place will be equal to what? 5%. All right. Now we have that 4% own a dog and a bird, all right? 4% own a dog and a bird. That means dog and a bird. This is dog and a bird. We have this. They did not say dog and bird only. If it was dog and bird only, we would have focused on just to this point, all right? If it was dog and bird only, we would have focused on just this point, leaving the place for the universal, right? But they said dog and bird, so it's a general for dog and bird, all right? So we're talking about this intersection down to this point and then here. So dog and a bird, okay, we are having what? 4%. So dog intersection bird to be giving us what? 4%. All right. Then we have what? 3% own a cat and a bird. So this is for cat and bird, not only, right? So we have cat and bird from this place. Also, it should be giving us what? cat intersection bed giving us what? 3%. I'm writing this out because it was not giving us as what? Only. Okay, now we have that 1%, okay, which is the major thing we're looking for. One, that is this place, this portion. 1% have all the three. That's this portion, right, of the Venn diagram. That 1% has both dog, cat, and what? The cat and bed, right? So when we are put our 1% here correctly, it means if we want to know the number of people that own a dog and bed only, all right, dog and bed only, will be less than 1% from 4%. That means we'll be having what? 3%. Okay, now if you want to know the number of people that have what? A bed and a cat only, okay, just a bed and a cat alone, we're going to be lessing this same 1% from 3% to have what? 2%. If you want to have people that own both what? Dog and cat, okay, that's this portion only, all right, just this portion, are going to be lessing 1% from 5%, okay, to give us what? 4%. All right, now we have shown our Venn diagram. Okay, now in this case, like I said, whenever you want to have your only, you have to subtract all the intersection, right? That means if you want to know the number of people that have dog alone, just this portion, all right, without the intersection, number of people that have dog alone, okay, we're going to be subtracting 1, 2, 3 from this. Okay, so we're going to be having 20% minus 4% minus 3% minus what? 1%. So we're going to be left with what? 12%. That means 12% of this population own dog alone. All right, now the next we're going to be looking at, when we want to come to cats, people that own cats only, we'll still do the same thing. We're going to less the intersection. This is the entire circle, right? So we're going to be lessing 1, 2, 3 to get cats only. All right, when we say only, just this portion, all right, so we have cats only, we'll be lessing 30% minus 4% minus 1%, all right, and then minus what? 2%. Okay, and that will be giving us what? That will be giving us 27, right? 23%. We'll be having 23%, right? All right, now the last place we have for bed, people that own a bed, total number of people that own a bed is 40, right? That means this entire set, the elements, this entire set will sum up towards 40. All right, now we have gotten 3 for this intersection, 1 and 2. If we want to get people that own a bed, just one, only the bed, they don't have any other thing, okay, just the bed, we have to still less 1, 2, 3. So we'll be having 40 minus 3 minus 1 minus 2, right? This is 6, so we'll be having 34%. This is what our Venn diagram is. Now, if we are giving any provision for people that do not own either of these 3, that provision will be coming out, all right? That's our neither, right? So the other space in the box. Okay, now we are asked that what percentage of a street own at least one dog, at least, okay? When we have at least means the smallest should be just one dog, okay? So we want to see a dog and more. That's the other English, okay? But if they said at most one dog, okay, that means the highest thing they should have is just one, all right? That means they should not have 2. At most, the highest should be one dog. But when we have at least one dog, we are saying from one dog and what above, okay? Now, so we have what percentage of the street own at least one dog, one cat, or one bed. So in that case, we want to know the percentage of the street that own at least one, okay? If we want to say at least one, that means we are saying one and what above. All right, 1 and what above. Now, so we're going to be adding up 1 and above, right? We'll be adding people that have both those that have 1, those that have 2, and those that have what 3. So we're not looking at the neither in this case. All right. Now, so we're going to be having people that have at least one dog. Okay. For the number of people, the percentage that owns at least a dog, right? Cat, or what? Bed. That's what we're going to be working for. Okay, we'll be having 12. Those who have 1 will be coming first, plus 23 for our cat alone, right? And then plus 34% for our bed alone, right? Now we'll move to the second, which is intersection, right? Since we're having at least plus 4% plus 2%, and then lastly plus 1%. That's what we're asked to do. So we're adding from people that have 1 alone to those that have 2 alone, and then to those that have 3. So that will be giving us how many percent we'll be having. That will be giving us what? 79%. Okay, that means 79% of the community own what? At least 1 bird, 1 dog, and what? 1 cat. Are we together? So if 79% of these people owns that, alright? But if they have asked us at most, okay, they would have been looking at 1 and what? Below. Are we together? So with this, we've come to the end of discussion on the Venn diagram and our discussion on the set theory. I hope you'll be able to learn how to use Venn diagram to solve questions that relate to set, alright? So don't forget to like this video, share our video with as many as possible, subscribe to our channel if you haven't, click on the notification button so that when new videos drop, you'll be notified immediately. Okay, so we'll see you in our next class. Thank you.